to start today's lesson, what I want you to do is I want you to take a look at the sun, a tree, and a meter stick. All right. Now, the sun, tree, and meter stick, all right, could be used using similar triangles. Now, the reason for that is the distance the sun is away from the earth. So that's this thing right here. The key idea here is you need to basically take your measurements quickly. Now imagine if I could say move my tree and I could move my meter stick in such a way that I could basically position all these things in such a way that they're level on a level plane, on a level surface on the ground, right? Now, because the sun is so far away, we know that light travels in a straight line, does it not? Now, if it does, what we can do is we take, say, a light ray from, say, here, and follow it down all the way until it hits the ground. Now, if I take this tree and move it so that it just is in the edge of the light, what that allows me to do is it allows me to take my meter stick and position itself somewhere along the ground with this tree. Now, in doing so, what we've just done is we've created a right triangle for the outer edge of this scenario, but then we also have something going on here as well that is inscribed in it, and we prove that if we have an inscribed triangle with one shared angle, in this case A, and two corners, two heights that are both 90, we can clearly guess that this and this, using the F pattern, gives us X here and X here. So we have three angles that are identical, which means we have two similar triangles. Which means if I know the height of this first triangle, let's say this one, let's say it's a meter stick, so it's 1 meter. All right? And I know the length of its shadow, which is in this triangle here. I should be able to calculate the distance from here to here, or from here to here. Okay? But basically what we need is either this side as a full number. We either need this, or we need the length of the tree shadow in order to be able to find out what those things are. So earlier we showed that triangle ABC is similar to triangle XYZ, and all we have to do is we say that angle ABC is equal to angle XYZ, which is, and we also know that angle ACB is equal to angle XZY. And we also know from the F pattern that angle Y, that angle BAC BAC is equal to angle angle YXZ from the F pattern. Now, since all those three things are true, therefore, triangle ABC is equal to triangle, not equal to, but similar to triangle XYZ. Now, that triangle that we have here doesn't necessarily have to be inscribed in each other. Now, basically, the sun can be in any position as long as when we take our measurements of the shadow and the height of our reference object, i.e. the meter stick, and the shadow or the height of our tree, we need to do it quickly because the sun moves throughout the day. And the quicker we do this, the more accurate our calculations will be. Now, let's take a look at this problem here. It says, if the length of a stick is 1 meter, the height of the stick is 1 meter, and the shadow is 0.65. So I'm going to basically make my triangle. All right. And then I'll make my second triangle. So this is this is YXZ. And my second triangle based on my tree. So this one's going to be my tree. I know that its shadow is 34.1. And now all I need to know is this value x, where x equals the tree height. In meters. So based on that, you know that triangle ABC is similar to triangle XYZ. Yep. Which means that if I take a look at this side and this side, I can make a ratio for it. And then I could also take a look at this side of my triangle and this side of my triangle and make a ratio for it. And both would be similar. In this case, what you would do is I'm going to use the big over the small, which is going to be the following. Well, we're going to have AC over XY is going to equal BC over YZ. Now, we're just going to have to substitute those values. In this case, we've got, for AC, we have x over, well, its corresponding side is 1, which means the other side is going to be 34.1 divided by 0.65. And now we simply cross multiply. If you want, or you just solve right away. And we end up with the following. X is equal to 52.5 meters. Therefore, the height is 52.5 meters for the tree. And we use similar triangles to do it. Now, let's move on to the next topic. So, the next topic we have to look at is a thing called the scale factor, right? Now, the scale factor between any two triangles is what number we have to either multiply or divide by to get either the big triangle or the small triangle. Okay? Now, basically what we're going to do is I'm actually going to always use the big ratio divided by the small ratio. Now, imagine that I sat here and I actually calculated and made sure that these two triangles were similar. I've done that already. I made sure all the angles were correct. Everything works. So in order to figure it out, all we need to know is what one of the side ratios is. In this case, I'm going to choose 27 over 5. Because these two sides are the hypotenuses of these triangles, and they are the easiest things to spot. Use those when you do your calculations. When you calculate that, you end up with 27 over 5, which simplifies to a k value of 5.4. So what this tells us is that in order to move from the small triangle to the big triangle, we have to multiply by 5.4, but going backwards, we have to divide by 5.4. Now, how do these areas of the two triangles compare? Let's do that. We'll calculate the area of the big triangle and the small triangle, then compare. So, upon doing the calculations, we end up with something like this. The big area is 174.96, and the small area is 6. Now, let's go and take a ratio of the two areas. Now, if I take a ratio of the two areas, if I take the area of the big divided by the area of the small, we end up with 174.96 divided by 6, which is going to equal the following. Ends up 29.16, and upon closer inspection, you end up with 5.4 squared. So, what this tells us is the following. If I was looking at the areas of something, the area of the big is going to transform into the area of the small by doing exactly the same thing that we did before. We take our 5.4, but this time we take our ratio of lengths and square it instead because it's area. And then when we're going from here to here, we are dividing by 5.4 squared, whatever our value was. So, the big overarching discussion for the day is this. When we talk about the scale factor of something, right? When we're taking a look at the side lengths, this is what we've got. To go from small to big, we multiply by k. To go from big to small, we divide by the k value, i.e. the ratio of the lengths from big to small. Next, for this next one, when we're talking about the areas, we follow the same pattern again. Going from small to big, we multiply by k squared and divide by k squared to get the previous area. Now, what I'd like you to do for your homework is these questions. Have a good day.